Next topic will be the Thevenin's theorem. So it is the same again principle in DC network. So as applicable to AC networks, this theorem may be stated as follows. The current through a load impedance, ZL, connected across any two terminals, A and B of a linear network is given by VTH divided by the sum of the ZTH plus ZL, where your VTH is the open circuit voltage or the Thevenin voltage across A and B, and ZTH is the internal impedance of the voltage source replaced by the internal impedances and current sources by infinite impedance. So this is the summary or the Thevenin theorem. This terminal A and B will be our ZL, and we are required to solve for the current flowing in terminals A and B. So first is you will solve the Thevenin voltage in this open circuit voltage between terminals A and B. And after you solve the VOC or the VTH, next is you will solve for the Thevenin's impedance, Thevenin's or the Thevenin's impedance ZTH. By doing that, you need to short circuit or short all the voltage sources and then solve for the ZTH inwards. After solving ZTH, you are now ready to solve for the current flowing in this terminal, IL. For IL, simple Ohm's law lang, IL will be equal to the VTH divided by the ZTH plus ZL. Okay, so we will demonstrate example. For example, 15.13, we have this circuit Z1, Z2, Z3, and ZL. We are required to solve the current flowing in terminals A and B. This is our ZL. So Z1 is 8 plus J8, Z2, 8 minus J8, Z3 is 2 plus J20, and ZL is J10. Our source voltage is 10 angle 0. First is remove ZL from the circuit terminals A and B. Compute the open circuit voltage VOC or the VTH which appears across the terminals A and B. So we remove the ZL, and analyzing this circuit, for us to solve for VOC, isolve muna natin yung total current dito. So IT, since this is an open circuit, there is no current flowing in Z3. So we can say that Z1 and Z2 are in series. Solving IT, your ZT will be Z1 plus Z2. That is 8 plus J8 plus 8 minus J8 equal to 16 ohms. IT now will be terminal voltage or the source voltage 10 angle 0 divided by total impedance is equal to 16. So IT is equal to 0.625 amperes. Now, we are ready to solve for VOC. So as you can see, VOC is in parallel with Z2. So the drop in Z2, the voltage drop across this point Z2 is the same reading in your VOC or the VTH. So this one, that is VOC is equal to VTH. So drop in Z2 is equal to the current flowing in Z2 multiplied by the impedance 0.625 times 8 minus J8, that is 5 minus J5 volts. So VTH is equal to VOC is equal to the voltage drop in V2, that is equal to 5 minus, this is 5, J5. So this one is 5 minus J5 volts. Now, after we solve the VTH, okay na yung VTH. Next is the RTH or the ZTH. So this one is the ZTH. We will remove or short the source voltages, and solve for RTH. So we remove our source voltage here, the 10 volts, and then we will solve the ZTH inwards. So we will start at the back of the circuit. As you can see, Z1 and Z2 will be in parallel, and then the combination of these two will be in series with Z3. So Z1 in parallel with Z2 plus Z3 is equal to 10 plus J20 ohms. Now, after solving ZTH and VTH, you are now ready to solve IL. What you will do is redraw the circuit. RL will be, or ZL, will be in series with the ZTH connected to VTH. Now you are ready to solve the current flowing in ZL, which is your IL. The VTH, this is your RTH or ZTH, and it is in series with RL. IL now will simply be the Ohm's law. IL is equal to VTH divided by RTH plus RL. So, palitan nyo na lang ng Z itong mga to. IL now will be 5 minus J5 divided by 10 plus J20 plus J10. So, IL will be 5 minus 5I that is 0.224 angle negative 116.565 amperes. So this is now the value of your IL. You can recheck this one using different networks and laws and theorems that we discussed, and also simply the series parallel combination. So if you get the same answer, so that is correct. You can solve also the current flowing in Z3 using Thevenin's Z1 and Z2. Last example for Thevenin circuit or Thevenin theorem. Find the Thevenin equivalent circuit at terminals A and B of the circuit given in this figure. So this is our original circuit. We have 2 ohms, negative J8 ohms, connected to 100 angle 0 source, and in series with 4 ohms, as well as 60 angle 60 and 10 ohms. So we will find the VTH and ZTH of this circuit at terminal A and B. So first one is solve for VTH across terminals A and B. For us to solve A and B, the voltage across A and B, we need to solve first the current flowing in this circuit. So as you can see, there's no current flowing in 10 ohms because our circuit here is open. Only here because it is closed loop. Calculating the current at this loop, we have negative 4I minus 2I minus negative J8I plus 100 angle 0 by KVL equation is equal to 0. So solving for I, we have 100 angle 0 divided by 6 minus J8, that is 6 plus J8 amperes. Now we solve the current flowing in this loop. We will get the drop at 4 ohms. solve the drop in 4 ohms. So that is V is equal to IR. V is equal to I multiplied by 4 ohms. So 6 plus J8 times 4, that is 24 plus J32. Now, if we are going to have a loop, KVL loop at this portion, we have starting at 60 angle 60. So our loop entered into the positive sign of a source, negative, the parenthesis of 60 angle 60, and then entered into the positive sign of VTH, so minus VTH, entered into the positive sign of the 4 ohm or the drop in 4 ohm, that is minus 24 plus J32, entered into the negative sign of 100 angle 0. So that is positive 100 angle 0 is equal to 0. Solving this equation, we have VTH equal to 107.863 angle 100, negative 169.335 volts. Next is the ZTH or RTH. Shorting all the sources,